Good morning, everybody. It's my pleasure and honor to be here in Tbilisi. I consider Tbilisi my second home. My wife is Georgian, and it's great to be here. The intent of the presentation is really to share information with you. Intent-based network is new and exciting technology. So the idea is to share with you, and as Cyrus Tbilisi beautifully put it together, what we share makes us richer, what we don't share goes away. So let's review the landscape of IBM today. We have number of companies, number of solutions that take different views on what IBM is and trying to solve different pieces. However, if you cannot address all of your network, including services, including infrastructure, you get partial view, and this is pretty much what you see on the picture. You might see a leg, you might see some other part of the body. You won't see everything you need. The goal of IBM is to take a step back and have a holistic view of your infrastructure with services on top and business logic on top. If you look at the landscape of today, there's a number of scripting tools that gives you ability to configure stuff. Network independent such as Ansible, Chef, more connected networks such as Napalm. However, all of them are focusing on configuration, or in other words, day zero operations. There are a number of tools that are vendor dependent. We know some of them. The problem with them, they're vendor dependent. They are not multi-vendor, and intent-based networking is per definition multi-vendor. When you express your intent, you shouldn't care who is going to instantiate it, be it Cisco, Juniper, Arista, or whoever not, right? So the focus of this presentation, or second part of this presentation, is to talk about how do we do change validation, because this is the most complicated part. After you've built your network, you are moving to day 2 in 5 minutes. So how do you validate changes, either intended or unintended? How do you know whether change that has happened in your network is actually impactful? What does it mean to your services? What does it mean to your business logic? So the basic philosophy of intent-based networking is you're focusing on outcome. You're not focusing on configurational tasks. It's not how you do things, it's what you want it to be. If you look at full life cycle of intent-based networking, we have defined 4 different phases. So design phase, this is where you express your intent. You say, I want a network of particular size. It does particular things. And you might express some business logic. I want oversubscription of particular type. I want some other characteristics that are not vendor dependent. They give you ability to build a logical structure. When we move into build phase, you need to provide more resources, soft resources, hard resources. If we think about data center networking, you would need IP addresses that are going to be on the links, on loopbacks. You would need IS numbers. You would need some more soft resources in order to be able to actually model your networking. So the end result of build model is to build data model that represents your intent in vendor-independent way. The deploy phase is the phase where you make it vendor-dependent, because, as we know, vendors have difference in the ways they instantiate networking. The configuration way is very different from CLI on Cumulus and Cisco to netconf to many different things. And then validation phase is after your network is set up and running, and you need to continuously validate. You need to understand what your network is doing, whether what it's doing is in line with what you want it to be. So the goals of IBM is composition, decomposition, scale. We'll go in details what it really means. And how do we deal with changes? Is the change impactful? If I want to have a planned change, upgrade a device, add more links, remove more links, replace something, can I do it on 1 device, 10 devices? So your business logic, again, which is very high level, I want to upgrade my network, right, goes down to very specific things, such as, can I still provide enough bandwidth for my services to work? Closed loop validation. We are going to discuss in more detail again what I mean by that. Important point here, you need to be able to ask question from your network. Show me a path that particular application takes. Show me something that is in real time and independent of number of devices in my network, the way they're connected. So you decouple policy or query definition from what your network is. If it's today 20 devices, tomorrow 150 devices, your query is still exactly the same. So how do we deal with scale? We compose. Composition means we take simple tasks and build multi-layer, multi-dimensional task that is more complex as such, but gives ability to abstract semantics. And why do we model a graph? Networks are graphs. There are connected graphs. In case of data centers, there are densely connected graphs. So it's very intuitively to represent network as a set of nodes, edges, vertical, and relationship between them. The great property of a graph, the way you build your query, gives you ability to build new queries in real time. So you don't know what kind of question you are going to ask tomorrow. Maybe you know it today, but tomorrow. Having graph with well-defined nodes, objects, and relationships gives you ability to craft your query based on your business requirements. So for sake of this presentation, this is the network we are going to talk about model. It's really a data center network with 2 spines, 4 leaves, and 4 hosts connected to them. How do we compose the graph? Spines. Interfaces on the spines. Links connected to the interfaces on the spines. Interfaces on leaves. Leaves themselves. Interfaces on the leaves. And hosts. So as you could see, we've just represented physical network on the left as a graph on the right. How do we compose it functionally so we can go into build phase and build a network? This is all the nodes on your graph. We take a spine later, we validate it. We take a leaf layer, and again we validate it with particular semantics. We take host layer, and again we validate. So far we've got 3 layers that are not connected. We know that they have to be connected in a way, and most oftenly you will define connectivity based on oversubscription. So if you define oversubscription 1-to-1, you know that what comes in goes out, which gives you pretty much a clause. If your output is lower than your input, you build something that we know as fat tree or leaf spine networks of today. We connect the nodes in the graphs. Most importantly, at some point, we need to define services because network as such, it's infrastructure. The thing that makes your network run, that makes money, is our service. So we connect services to a node. In other words, if you have 2 servers that run an application between them and you need to connect them over a VPN, you'll represent them in the graph. This is the end result. So as you could see, there's an application that's connected to a number of hosts that are connected to a number of leaves. The query is very simple. Show me all the links that carry the traffic for this application. By having relationship defined, so you know who connects to the host, who connects to the leaf, you could easily see every switch that can possibly carry traffic for a particular application. Now you can understand if one of the links goes down, what is the impact on my application? Can I upgrade 1 or 2 or maybe 4 devices simultaneously, and I need to do it gradually? So ability to ask your network what it is in real time gives you ability to apply logic afterwards. So we've built full network with all the services. However, in order to understand, to comprehend what it does, you need to have also simple per layer representation. And here we're going to decomposition. What's decomposition? You take one big complex thing and you decompose it into smaller, simpler functions. So well-known function in the math, right? So let's take a walk through the graph and see how decomposition happens. What you see now is full graph of connected nodes of the network before. What you see on the left is a query language called GraphQL. It's very well used in the industry, well known. So what you see now is a node in the graph that represents spines. Now I want to see all the links on the spines. Now I see all the leaves. And eventually, by walking the graph, now I've built my full 4x2 network with all the links. Why is it of interest? Now I can easily walk every link between every spine to every leaf to every server and know exactly what it is, all the nodes. I can provide proof of transit. I can do many things to validate whether my network is working. So as you could see, in this case, my query is show me all the paths available between every leaf to every spine. And there should be 8. We multiplied 4x2, right? And this is what we see. What's important here in layer 3 ECMP-based networks, you don't know what the paths are because your packet can take any path that's available through ECMP. By being able to model it properly, you could easily derive which links those are, and then by looking into application, you know which links are being used for a particular application. Very useful for troubleshooting, very useful sorry, very useful to figuring out impact of an outage. We know there's a thing called elephant-mouse flows. So elephant flows are fat flows that use a lot of bandwidth. Mouse flows are small, and if small flow gets behind the fat flow, it might get longer time to traverse the network. So by being able to figure out what's going on, you could actually influence behavior of your network. There are ways to change hashing buckets. We are not going to go in, but by knowing what your network does, you can change the behavior. Let's talk about analytics. Looks familiar to everybody, right? So if you look at any enterprise saying, we are using big data, what they really mean, we are gathering terabytes of data that go into our data lakes, and we never look at them. We have no idea what they do. We just have the data. It's unacceptable from analytical perspective. It's unacceptable from pure cost of storage. It takes money. It takes electricity, cooling to store the data. So the very important part of intent-based networking is to ask for right data. Let's take an example. This is high-definition telemetry for an interface on a switch. Now I see all interfaces on a single switch. Now I see all the interfaces on all my leaf switches. What does it tell you? It tells absolutely nothing. How do I figure out? It's a very simple question. Show me all the links between leaves and spine and how they're loaded. If you do it manually, good luck. So how can you do it in a way that is independent of number of switches? Remember, you've just abstracted a link between leaf 1 and spine 1 by saying, show me all the links that have particular property. There are links between all the leaves and all the spines. Your query is going to be, show me all the links that are between all the leaves and spines. Now in real time, you can also express your business logic. You could say, I consider my fabric healthy if it's not overloaded in particular amount of time, because it could be overloaded in 1 second and underloaded in another based on traffic characteristics from the application. So you could say, I consider it overloaded if it's loaded more than 3% in 2 minutes out of 7. You can keep adding additional logic into your queries in real time. And again, it's important because it's application-driven. You don't look at your network separately from your application. You know, hopefully, exactly what your application needs. So in this case, you figure out that your network is overloaded. You've measured number of times what is the average load on every link between leaf and spine for 7 minutes, which is your business logic, and it gave you end result, my network is unhealthy. I need to do something, I need to remediate, I need to upgrade, I need to add more links, I need to reduce the amount of application. If you think about more complex use cases, such as integration with cloud management, VMware, you might just evacuate your VM to some other place. Kubernetes, you might decide to instantiate your pod in other part of the network. So, in other words, if you build your query that it can address your graph, you could ask your network any question you like in real time. So to show kind of picture what it looks like, an IBM system should provide you a set of APIs to express your logic in terms of show me a common view of my network from a particular angle. So it could be show me all the links between leaves and spines. It could be show me all the links that are connected to my Cisco switch. Show me every switch that is Arista. Show me every switch that has Hadoop application connected to it. So by abstracting the physical links and logically grouping them in a particular way, in a way that is important to you, you are able to build queries that tell you exactly what your network does. And to do so, you don't need all the analytics. You don't need to see it on terabytes of data. You do it in real time. Obviously, there's a number of things you need to know all the time. Are my interfaces up and down? Are my BGP sessions up and down? What is the average load on my interfaces? We could think about 10 to 15 things that need to be gathered at any time in the network. However, there are 150 other things that you don't need to know unless your network breaks down. If we go into overlays, EVPN has very complicated troubleshooting workflow. However, if you could see that your overlay works, you see all the routes that should be there. All the routes have right next hops and all the attributes. There's really no need to go and gather all other data. Your network is working, you leave it alone. So to conclude, basic automation has been there for the last 30 years. We all remember tackle interfaces on Cisco's. You could do some stuff on Juniper for quite some time. However, it's still per box view. It gives you per box details. You go to next box. You cannot correlate what you see there versus first box, right? So while you could do things in automatic way, it doesn't really result in better networking, in faster networking, in ability to deploy your application faster. Single source of truth. You need to have a place in your system where all the data is coming together. Network is complex today. If you think data center, at least you've got your underlay, you've got number of protocols you could use to distribute reachability, BGP, SAS, OSPF, and so forth. You've got your overlay that could be routing driven, so EVPN. It could be cloud managed driven, being NSXT, being OpenStack, being Kubernetes. You might have your optical layer to provide DCI. You might have your traffic engineering on top of your optical layer to provide traffic engineering across data centers. So unless you can bring all this data in a single place where you can analyze it, you could take a snapshot of your network that's multidimensional and multi-layer and apply your logic to it. The analytics you gather are meaningless. They don't mean anything unless it could be seen as a part of system. So I think we could consider automation as pretty much done deal. Again, there's a number of tools you could use today that would go and configure your device a particular way. What's really complex and to my liking, most complex area in intent-based networking is really data operations. How do I manage my network? What happens when there is a change? Can I do a change on my network without affecting my application? So we are talking here about context that drives the content of what I ask my network. You don't need to ask everything. You don't need to have 2 racks of tetraration stuff, just gathering stuff, just in case. You need to know what to ask. When you know what to ask, you could ask right questions. You could ask, can I change anything? My interface is down. What does it mean? Configuration drift is another very interesting point. So traditionally, for the last 30 years, we've been dealing with router configuration, switch configuration as source of truth. It's really wrong. It's the other way around. Your configuration of the device is a rendering of your intent. So what's really the true store for your data is where you consume it from the OSS, BSS, or cloud management. It can be the configuration. So configuration is the end result. You cannot rely on it to tell you what it is. You should know what it should be in order for your network to work. And this remediates configuration drift because you've configured your network. 10 minutes later, someone goes into CLI and changes something. 20 minutes later, another person goes into CLI and changes something. Now you don't know what your network is doing. You don't know what particular person did. And you just got out of sync between you wanted your network to do and what it's doing now. By having single source of truth that is always in sync with your intent, you remediate the configuration drift. And again, it's one of the largest problems in today's networking. Remediation, after you figure out how to gather your data, what it means to you, you could go to marketing terms, self-driving, self-healing, self-working network, because now you can auto-remediate because you know what is wrong. The difference between intended state, so what you wanted it to be, and operational state, what your network is doing. So that brings us to really working system that most of the time does things that you want it to do, and if it doesn't, it can auto-remediate. Questions?
It's working and turn it on. Evgeny Zobnis of Factor Group. I just wanted to say big thank you for the presentation. And I have a question about how complex topology can be and what kind of devices we have to use to be able to model it.
So, first part of the question, the easiest way to deal with topologies is when topologies are regular. So if you look at data center, if you are building non-spine leaf network today, I would really ask you why. And what did you do to yourself? So from data center perspective, what we see today is always a way of leaf-spine network being 3-stage, 5, 7, depending on the size of your network. Right? So this network is highly regular. The topology is well understood. The routing is well understood. So while building your network, you can exactly understand the outcome. You can build expectations to what your outcome should be, how your BGP routing should look, how next hop should look. So by building it, you immediately create expectations to what normal state should be.
And what type of the devices, what vendors do you support?
So intent-based networking, per definition, should be multi-vendor, or actually vendor agnostic, because the way you get your intent, it doesn't say, I want you to deploy Cisco. It says, I want you to deploy a network that has number of nodes in it, has number of links with it, with particular characteristics. So per definition, if you hear it's intent-based network, but it supports only Cisco switches, I would argue it's not really intent.
Thank you.
Okay, time for one more question.
Michael Kartolishvili, SilkNet. My question is, when using your system, it's not always that easy that all the networking problems and intentions can go to links up and links down. Some of the problem are links still up, but there is something else like MTU problem and so on. So is intent-based networking able to identify these things that sometimes go into some vendor-specific forests?
So to begin, I didn't present my company, I present the technology. I'm not in sales, right? Number one. To answer your question, I'm not taking existing configuration and think what it does. The intent-based system is creating configuration. So if MTU should be 9K in every switch, then it should be 9K. And if it's not, you should be able to see that there's deviation between what you wanted it to be, what it is. With regards to testing, there's a number of upcoming solutions. We know them as in-band telemetry, VXLAN telemetry, so draft test in ATF. They give us ability to instantiate probe from every device and say, is it working? Did it traverse all the switches it needed to traverse? So the more data we get, the more precise we can identify whether my network is working. And to your point, gray failure are the hardest to find. However, if you know what question to ask, could be as simple, show me MTU on all the links between leaves and spines. You could pre-validate your network before taking it to production.
Thank you.
Thank you, everyone. Madlub.